Hello, my lovely viewers. Welcome again to Maths Buddies and I. It's your presenter Jefferson, and today we are still working on logarithm. Yeah, we have 3 questions on the board, and remember in our last class I told you guys we will be looking at in our next video logarithm with different bases when the bases are not the same. Now, what we treated in our last video was all the bases are the same, and we know how we can work with that. Now, you will notice that in question number 1, the base here is 3, the base is 9, and the base is 16. They are all different. Now, how do you work with questions that the bases are not the same? Because there is no way in this case that plus can change to times or that minus can change to division, because the bases are different. Now, how do we go about it? Let's begin the class. Okay, now question number 1 says, evaluate log 9 to the base of 3 plus log 3 to the base of 9 minus log 4 to the base of 16. Now, this is the question they said we should evaluate. Now, we now see the bases are the same, so we can also apply the laws of indices here now that says addition becomes multiplication and subtraction becomes division. And there is no way I can pick one base because the bases are different. Now, what do? We solve this separate, we solve this separate, and we solve this separate. Now, let's see. The number here is 9, the base is 3. Now, what do? I break 9 to base 3. And how do I do that? By multiplying 3 into 2 places. 3 times 3, 9. So it means log, the number 9 is the same thing as log 3 raised to the power of 2 to the base of 3 plus, now, the number here is 3, but the base is 9. I also break 9 to 3. So here becomes plus log 3. Then base 9 now becomes 3 raised to the power of 2. Now, minus. Now, log 4 base 16. 4 and 16 has a number that we can break both to, which is what? 2. So if I multiply 2 to get 4, it is 2 times, which is 2 raised to the power of 2. So here becomes minus log 2 raised to the power of 2. Now I multiply 2 4 times, 2 times 2 times 2 times 2 to get 16. And here becomes base 2 raised to the power of 2 as well. Now, coming back to the laws of indices, which is called the power law, we said that when the number carries a power, the power goes to the back. So here becomes 2 log 3 to the base of 3 plus. Now, the base is carrying power 2. Also, the number is also carrying a power. But the power is not there. But what power is there? Power 1. When the number stands alone without the power is 1. So automatically, we said that in the power law of logarithm, when the number and the base carries a power, when both of them carries power, what happens? The powers goes to the back and become a fraction. So if 1 and 2 goes to the back, it becomes 1 over 2, which is the fraction. Then what we're going to have here? Log 3 to the base of 3. And also minus 2 over, this is supposed to be 2 raised to the power 4, Now, 2 over 4 goes back also to becomes 2 over 4. Then what do we have there? Log 2 to the base of 2. Now, without wasting time, the law that says when the number and the base are the same, what is the result? 1. So it means log 3 base 3 is 1. Now, what do we have left here? 2 plus log 3 base 3 also is 1. What do we have left here? 1 over 2 minus log 2 base 2 is 1. What do we have left here? 2 over 4. Now, this is fraction. Now, what do? Base 2 over 1 and look for the LCM. Now, we look for the LCM of the denominators, which is 1, 2, and 4. Now, the LCM of 1, 2, and 4 will give us 4. Now, how many times will 1 divide 4? 4 times. 4 times 2 will give us 8. Plus, how many times will 2 divide 4? 2 times. 2 times 1 will give us 2. Minus 4 divide 4, 1. 1 times 2 will give us 2. So what do we have, class? 8 plus 2 gives us 10, and 10 minus 2 gives us 8. So here becomes 8 over 4. And class, 8 divided by 4 will give us 2. So now you can see how you work with logarithms when the bases are different. Try to solve them one after the other, not grouping them together. Because when you try to pick a log here, it won't work because the bases are different. But when the bases are the same, it is another case. It can work. Plus becomes multiplication and minus becomes what? Division. Now, going to question number 2, you will notice that question number 2 is far different from question number 1. The question says, if log 4 base x equals to 1 over 2, calculate log x base 2. Now, before I will proceed, let me introduce you to another law called, on logarithm, called the reciprocal law. The reciprocal law. Now, the reciprocal law says if I have log x base y. Now, notice the base is y, the number is x. If I want to make the number x become the base and the base becomes the number, I simply do the reciprocal. So it becomes 1 over, now the log comes down. Here becomes log. Now, my number now becomes y, and then my base becomes x. Reciprocal law. Now, this is the law we will be applying to solve question number 2. Now, let us see how it goes. Without wasting time, we have this. If log 4 base x is equal to 1 over 2, evaluate or calculate log x base 2. Now, let us see. In this question, we are told to evaluate. The number is x. But in the original question, the base is x. Now, let us go with this man step by step. Now, the first thing I have to do is to bring this number 4 to base 2. Now, base number 4 in base 2 is 2 raised to the power 2. So here becomes log. It becomes log 2 raised to the power of 2, so the base of x is equal to 1 over 2. Now, power law says when the power is here, it goes to the back. So here becomes 2 log 2 base x is equal to 1 over 2. Now, what they said we should calculate is x base 2. But what we are having here is 2 base x. Now, we just said it. How can I make x becomes the number and 2 becomes the base? Reciprocal law. So when I reciprocate this law, it becomes 1 over, when it comes down, 2 log. Now x becomes the number and 2 becomes the base. Equal to 1 over 2. Class, without wasting time, cross multiply. When you cross multiply, 2 log x base 2 times 1 will still give us 2 log x base 2. 2 times 1 will give us 2. Now, we are looking for log x base 2. Now, for log x base 2 to be the subject of the formula, anything that makes log x base 2 to not stand alone has to leave. And what is that? This 2 here. So what do we do to remove this 2? We divide both sides by 2. Now, when you divide here by 2 and you divide here by 2, when 2 cancel out 2, what we have left in the question? Log x base 2 is equal to 2 divided by 2 will give us 1. That is the answer to that question. Log x base 2 is 1. Now, classical. The last question which we have today is question number 3. And the question says, if log x base 2 equal to 3 plus log y base 2, find the value of x over y. Find the value of x over y. Now, how do we go about this question? Let us begin. Now, without wasting time, log number 3, log x to the base of 2 is equal to 3 plus log y to the base of 2. Okay, now they said find the value of x over y. Now let us see. The base here is 2, the base here is 2. Now let's log with same base goes to one place. Now, when log y base 2 crosses the equality sign to meet log x base 2, it becomes minus log y base 2, because when plus crosses an equality sign, it becomes negative. And when negative crosses an equality sign, it becomes positive. Now, working with this illustration, we have this log x base 2. When plus log y base 2 crosses, that becomes minus log y base 2 equals, what do I have here, class? Equals to 3. Now remember, what are we looking for? We are looking for x over y. Now let's take a look at this question, class. I told you, observe the base. The base is very important to observe the base. Now the base here is 2. The base here is 2. They are the same. So what will I do? I'll pick one of the base. One of the log. I'll open a bracket. Now my first number here is x. Minus becomes divided by what? By y. All to the base of 2. Now you see, it is so simple to do that. It was so easy for minus to become division, because why? The base are the same. If you take a look at question number 1, our minus could not become division, because why? The base are different. Equal to 3. Aha! Now without wasting time, I'm going to introduce to you now another law. It is called equational law. It says, watch. If log x base y equal to n, comma, now y raised to power n is equal to x. The base will carry this as a power equal to your number here. Now, if you take a look at this law and this question, they are the same. How? My x is represented by x over y here. My y, which is your base, is represented by base 2. My n is represented by 3. Now, what will I do? It means just the way y carry n as a power, 2 will carry 3 as a power. So it becomes 2 raised to the power of 3 is equal to what comes here now? X over y. Class, what does 2 raised to the power of 3 mean? 2 times 2 times 2, and that is 8. Therefore, x over y is equal to 8. So class, we have come to the end of today's class with the 3 questions on the board, and I hope you have learned something new today. Please don't forget to subscribe to our YouTube channel, and don't forget to comment, and don't forget to share, so that we can spread the good news to those that needs this. Thank you very much. Till we meet again in our next class, don't forget, my name remains Jeff Nino. God bless you.